All right, guys, Mr. Antonucci here again, and I want to talk to you about how to factor trinomials where the leading coefficient is 1. But before I do that, I want to really show you where this method of factoring comes from. It's basically reverse foiling. So if I have x plus 2 times x plus 3, product of two binomials, and we do the FOIL method. You do the first, gives you x squared, the outers gives you plus 3x, the inners gives you plus 2x, and the last gives you plus 6. When you simplify that, you get x squared plus 6x, excuse me, not 6x, 5x, because you're combining these like terms, plus 6. Now, what I want to draw your attention to is that this 6 came from the product of the two constants, and the 5 came from the sum of the outer and inner terms. And so those are both made with 3 and 2. Notice when you multiply 3 and 2, you get the 6, and when you add the 3 and 2, you get the 5. So that's always going to kind of be the case when you're factoring a trinomial where the leading coefficient is 1. When I say the leading coefficient is 1, I'm talking about the number in front of the x squared. Okay, so one of the things that you want to always do is make sure that your trinomial is what we call standard form. Standard form just means that it's in order by the exponents. You have the x squared first, then the x, then the number. So now when we factor this one, you know you're going to have an x here and an x here. You want numbers that multiply to 42 and add to -1. Because remember, if we FOIL this out, the outer and inner terms are going to add together to give us -1, and they're going to multiply together to give us -42. Now, you could probably do this in your head once you get good at it. But two numbers that multiply to -42, we want to list the factors of -42. But also, they have to add to -1. So when I start listing the factors, I know 1 times 42 gives me 42. One of those is going to have to be negative. The bigger number is going to have to be negative because when I add them together, I want it to get to -1. Well, when I add 1 and -42 together, I'm not going to get -1. So you could go 2 and 21. That's still not going to give you -1. In fact, you're not going to get there until you get to the factor of 6 and -7. 6 times 7 is 42. 6 times -7 is -42. Now, how we know that the 7 has to be negative and not the 6 is because that middle term has to be -1. Notice that the 6 and -7 add to -1, and they also multiply to -42. So this is plus 6 here and -7 here, and that is our answer. Also, had you written it as x minus 7 and x plus 6, that would be okay, because you still FOIL that out, you'd still get x squared minus x minus 42. Not a problem. Just don't switch the signs on the 6 and on the 7. Don't make it x plus 7 and x minus 6. One other thing that I want to bring to your attention is sometimes you're asked to solve the equation where this is set equal to 0. It's the same process. You factor the equation into a product of two binomials. And here's the important part. There's something called the zero product property. On the sidebar here, it says if two quantities multiplied together equal 0, then either the first factor has to equal 0 or the other factor has to equal 0. This only works when your equation is set equal to 0, because in order to have a multiplication problem where the answer is 0, one of the things multiplying has to be equal 0. So once you factor it, now you have it as a multiplication problem, and you could set each factor equal to 0. X plus 6 equals 0, and x minus 7 equals 0. This factor would give you x equals -6, and this factor would give you x equals 7. And there you have your two solutions, and you could check them by plugging them into the original equation. If you plug in -6, simplify it, you get 0. Same thing with 7. want to do one more with you real quick, just to show you how we could do this. In this case, we have y squared plus 7y minus 18. If we want to factor that, we know that you're going to have a y and a y here, because the firsts have to multiply to y squared. The leading coefficient is 1, so we can use our method. Factors of negative 18 that add to 7. So the bigger number has to be positive because we're adding to positive 7. So if you start listing factors of negative 18, 1 and 18 isn't really going to work. You have negative 2 and 9. Those add to positive 7 and also multiply to negative 18. So those are our two factors. So y minus 2 and y plus 9. Again, if this was set equal to 0, you could set your two factors equal to 0 and set each factor equal to 0. And then you'd get your solutions y equals 2 and y equals negative 9. Okay, the original problem, though, in this case, asked us to factor the trinomial, so I'll box it in yellow. All right, so there you go, guys. Hope that was helpful to you to have a couple examples of how to factor a trinomial where the leading coefficient is just 1. If you have a math problem that you'd like me to try to make a video on, you can put it in the comments below, and make sure you subscribe to the channel, hit the bell for notifications when new videos are uploaded, and feel free to share this video with anybody that you think might be helped by it. All right, guys, take care.